Okay, problem 4. Yip, yip, yippee. So, problem 4, the Earth orbits the Sun in this nearly circular orbit with a radius of 149.6 million kilometers. So, I'm just going to go ahead and draw. Here's our Sun, and here's our Earth, and they have a radius, or the orbit. The Earth has a radius of, say, a little r here, and then we want to find, it goes around in a circle in 1 year, which is 365.25 days, and we want to find what the sun's, or what g times the mass of the sun is. Okay, so we want to find the GMS value, which is the sun's equivalent of g times me. So here is the force, the gravitational force that the sun exerts on the Earth. And that is what's keeping the Earth going in a circle. So let's take a different color there. And we know, we know the period of the Earth's orbit is 365.26 days. That doesn't quite seem right, but whatever. Okay, 365.26 days. And yes, so again, like with the geosynchronous orbit, we can we can find omega, which is 2 pi over t. Remember, you want to convert t into seconds first, so something there, okay? And then we can do our little circular motion analysis. And why does that little dot keep showing up? Okay. And we can do our circular motion analysis and say, okay, so A equals A, and I'm really going to say MA equals MA. So 1 MA is the net force in the object, which is just the gravitational force. Okay, so that's going to be Fg, and on this side, the A is going to be omega squared R. I'm doing that instead of V because we have omega handy, much handier than V. Okay, so here we go with good old capital G, mass of the sun times, and actually what I'm going to do is I'm going to do mass of the Earth over r squared, and in this case is going to be the radius of the Earth's orbit, and that is going to equal, these actually should all be MEs here, and they should all be capital M, so I'm playing it I'm changing notation halfway through, but that's going to equal mass of the Earth times omega squared times r. So now what we want to do is, no, that's not what I want. I'm just going to switch to red because it's a nice crossy out color. And boom. No, stop it. Arg. Okay, now, boom. Oh, come on. This is really ruining the drama here. Okay, so now finally, no, that's why. That's because I've got the wrong tool. Wow, Smith. Nice job. Boom! Boom! That was... okay, not as much fun as I'd hoped. So what the hell are we trying to find here? Right, we're trying to find GMS. So I'm going to rearrange this to leave GMS alone on the left-hand side. And I'll put parentheses around it just to make it feel special. And that's going to be equal to omega squared times r cubed. Or if you want to plug in for omega, it's going to be equal to 4 pi squared. Okay, let's try again. Okay, it's going to equal 4 pi squared times r cubed over t squared. And so then all you have to do is actually plug in numbers there, and well, that's going to be the time-consuming part. So we can just sit here while I plug in numbers. So 4 times pi squared times, let me just show you something while we do this. That is our cat, Sydney, who I'm sad to say passed away about 2 weeks ago. She got sick and, wasn't going to make it back. She lived a long life. She was very happy. She was very cute. She was 15 years old. This picture was taken a couple of months before she died, so you can see she was cute right at the end. So, yeah, anyway. I keep her now on my home screen on this tablet just because it reminds me of her, and I like her. I miss her. Okay, so sorry, I'm almost done here. So I'm just typing in 365.26 times 24 times 60. No, not quite. Okay, times 60, and then we want to square that. And what I'm getting now, I hope this is right. I think so, yes. Okay, so what I'm getting now is, let's go back to our problem. Bye, Sydney. Oh, bye, girl. Okay, so GMS is going to be, well, it's a huge number. Now I have to count the number of digits. 1 point. Okay, is going to be. See, that's supposed to be an equal sign. Okay, is going to be 1.327 times 10 to the 11 meters cubed per second squared. And so that was one thing we wanted from this problem. The other thing, I think, was to find the ratio of the sun's mass to the Earth's mass. So what I'm going to do there, excuse me, Mr. Orbit, I'm just going to erase part of you. Okay, what I'm going to do there is say that the ratio of the sun's mass to the Earth's mass would be equal to the ratio of GMS to GME. And GMS we just found. GME we've used in every previous problem. Sorry about that little jerk there on the whatever. Okay, so anyway, I'm going to take what I just found here. So to be clear, just in case I wasn't clear, we knew GME from previous problems, right? Here, this here is GME. Okay, so now we go to here and we take this and divide it by 3.98 times 10 to the 14th. And, oh my god, no, that's way wrong. What did I do wrong here? I must have gotten my millions of kilometers and my thousands of kilometers messed up. That's what I did. So, yeah, ha 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 ha, there we go. Okay, so this is going to be not times 10 to the 11, but times 10 to the 20. Is that? Yeah, that's right. Okay, wow. Big difference there, huh? Okay, so, but other than that, it's correct. Let me make sure I've got the right number of zeros on this. 600,000 kilometers. Yeah, okay, so now I've got this correct. So let me, sorry for taking so much time on this, but okay. Times 10 to the 20 cubic meters, or meters cubed per second squared. Don't say, I mean, you'll never talk about this, but if you say cubic meters here, people think you're actually talking about a volume, and it doesn't really make sense. Don't try to intuitively understand these numbers. They just don't make any sense. Okay, so let me just pretty that up because I'm really annoyed by the way that looked. Okay, so now we take that and divide it by 3.98 E14, and we get, that's a little better. So this is going to be equal to, and I get 333,500 is our ratio of the sun's mass to the Earth's mass. So, and again, I want to point out this is something that, Newton could figure out, that the sun has a mass 333,000 times the mass of Earth. But he still could not figure out what the mass of the Earth or the mass of the sun actually are. All he could find was this ratio here, because he still didn't know what big G was. It wasn't until Cavendish that anyone knew big G. Anyway, so that's the answer to problem 4.